Hello, my dear students. Good afternoon, everyone. Here I am to take the Chemistry 1 class for the students of Standard 12. Welcome to my class. Today our topic is concept of pH and pH scale. pH. Before knowing what is pH, we should know why does the term pH come. Actually, pH is used to express the concentration of hydrogen ion in solution. And you know that in aqueous solution there is either more or less hydrogen ion present. In different experimental works related to biology, biochemistry, medical science, etc., dilute solutions of acids and bases are used. So, the concentration of hydrogen ion and hydroxyl ion in these solutions are very less, and their value is with negative power of 10, like 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3, up to 10 to the power minus 14. And you know, ionic product of water is also a value with negative power of 10, that is 10 to the power minus 14. To use these numbers with negative exponents is a troublesome matter. So to handle this problem, a Scandinavian chemist Sorensen in 1909 introduced a new unit called pH scale. He also introduced pH here to express hydrogen ion concentration. Now what is pH? The negative logarithm of the molar concentration of hydrogen ion in a solution is called pH of that solution. That means pH equal minus log concentration of hydrogen ion. Here, if anyone can know the pH of a solution, he also can find out the concentration of hydrogen ion by using this formula. Concentration of hydrogen ion equal 10 to the power minus pH. So from these two equations, we can tell that the higher the concentration of hydrogen ion, the lower is pH. And the solution which has lower concentration of hydrogen ion, its pH value is more. The decrease of pH by 1 unit means the increase of hydrogen ion by 10 times. Similarly, the increase of pH by 1 unit means the decrease of hydrogen ion by 10 times. In the same way, pOH also we can explain. pOH is the negative logarithm of the molar concentration of hydroxyl ion in a solution. Negative logarithm of molar concentration of hydroxyl ion. pOH equal minus log concentration of hydroxyl ion. Here also, if you can calculate hydroxyl ion concentration from pOH, you can use this formula. Concentration of hydroxyl ion equal 10 to the power minus pOH. Here also we can tell the higher the concentration of hydroxyl ion, the lower is pOH. And the decrease of pOH by 1 unit means the increase of concentration of hydroxyl ion by 10 times. Similarly, the increase of pOH by 1 unit means the decrease of concentration of hydroxyl ion by 10 times. pH scale. What is pH scale? The scale by which the acidity or basicity of a solution is expressed through its pH value is called pH scale. pH scale is a scale by which the acidity or basicity of a solution is expressed by using pH value. Look, the water is dissociated to produce hydrogen ion and hydroxyl ion, and we know the ionic product of water equal concentration of hydrogen ion into concentration of hydroxyl ion. And also we know that at 25 degrees Celsius temperature, the ionic product of water equal 1 into 10 to the power minus 14. Now, in this equation, If we take log on both sides, then we will get log concentration of hydrogen ion plus log concentration of hydroxyl ion equal minus 14. Now if you take minus sign, then we will get this. Now look, what is this? Minus log concentration of hydrogen ion. This is what? This is PaS and this is POS. So from this equation we can write PaS plus POS equal 14. This is an important equation for every aqueous solution. That means an aqueous solution has, if it has pH 1, then its POS equal 13. If it has pH 12 or 10, then its POS will be 2 or 4. That means every aqueous solution has its pH or POS value. Now, we know in case of pure water, the molar concentration of hydrogen ion and hydroxyl ion is equal. That means concentration of hydrogen ion equal concentration of hydroxyl ion. And if we put here hydrogen ion instead of hydroxyl ion, then the equation comes like this. And from there we can write concentration of hydrogen ion equal 10 to the power minus 7. Now, pH equal minus log concentration of hydrogen ion. So if we put the value here, then we get for pure water the pH value of it is 7. This is the pH scale. Here these are the pH value from 0 to 14 and also the color of pH paper. If the solution has pH 0 or very less, then the color is red, orange, deep yellow, light yellow, light green, deep green, and gradually it becomes deep blue. From pH 0 to below 7, the solution is acidic. From pH above 7 to 14, the solution is alkaline. And for pH 7, the solution becomes neutral. Look, there is another pH scale here with pH value. Some examples of solution are given. For example, there is the solution pH 13. Suppose bleaching powder. It has pH value 13. Or gastric acid, that means hydrochloric acid. It has pH value 1. Here distilled water, pure water. It has pH value 7. This is also a pH scale. Now look, already we knew that the pure water, it has pH value 7. If a small amount of acid is added into pure water, the concentration of hydrogen ion increases due to dissociation of the acid. Acid is dissociated to produce hydrogen ion and the concentration of hydrogen ion is increased for this. As a result, pH of that solution decreases below 7 and the solution becomes acidic. Hence, since the concentration of hydrogen ion is increased, its pH value becomes decreased and it becomes below 7 and the solution becomes acidic. On the other hand, if a small amount of base is added into pure water, the concentration of hydroxyl ion increases due to dissociation of the base. Base produces hydroxyl ion and the concentration of hydroxyl ion is increased for this. And according to chemical equilibrium, since the concentration of hydroxyl ion is increased, so the concentration of hydrogen ion is decreased, and as a result, for decreasing the concentration of hydrogen ion, the pH value is increased and it becomes above 7 and the solution becomes basic. Now look, there is another pH scale. Here in this scale, the pH value, POS value, the concentration of hydrogen ion and the concentration of hydroxyl ion, everything is given. Look, suppose a solution it has pH 1, then its concentration of hydrogen ion will be 10 to the power minus 1. So its POS will be 13 and its concentration of hydroxyl ion will be 10 to the power minus 13. A solution which has pH 13, its concentration of hydrogen ion will be 10 to the power minus 13 and its concentration of hydroxyl ion will be 10 to the power minus 1 and its pOH value will be 1. Now, from all these pH scale, we can tell if pH of a solution is equal to 7, the solution is neutral. If pH of a solution is lower than 7, the solution is acidic. And if pH of a solution is higher than 7, the solution is basic. So, in this session, I have shown you 3 pH scale. From there, this is the best because here the with pH value, here pOH, concentration of hydrogen ion and concentration of hydroxyl ion, everything are shown there. Now, from there, we will solve some problem. These problems are from your book exercise. In your book exercise, there are many problems. From there, I have shown you some. The others you will do in home. Problem 4.47c. Calculate the pH of 0.05 molar sulfuric acid solution. To calculate pH of a solution, we have to know about the concentration of hydrogen ion. Here, sulfuric acid, when it is dissociated, it will produce hydrogen ion. And it is strong acid, so it will be dissociated 100%. So, from 0.05 molar sulfuric acid, we will get 2 into 0.05 molar hydrogen ion, because from 1 molar sulfuric acid we get 2 molar hydrogen ion. So, from 0.05 molar sulfuric acid we will get 0.1 molar hydrogen ion. Now you got the concentration of hydrogen ion. From there you can calculate the pH value of sulfuric acid. We know pH equal minus log concentration of hydrogen ion, and if you put the value of hydrogen ion concentration, you will get pH of sulfuric acid equal 1. This is the pH of 0.05 molar sulfuric acid solution. Now problem 4.47g. Calculate the pH of 2.5% sodium hydroxide solution. Look, here you have to calculate the pH of sodium hydroxide solution. After dissociation, sodium hydroxide will give hydroxyl ion. So, from there, at first we have to calculate the pOH of sodium hydroxide. After calculating pOH, we can calculate pH from this pOH value. But here there is given 2.5% sodium hydroxide. You can calculate the molarity of sodium hydroxide from this percentage. Already you have learnt this. 2.5% sodium hydroxide means 2.5 gram sodium hydroxide dissolved in 100 ml solution. That means 25 gram dissolved in 1 liter solution. So, we will calculate its molarity. That means we will calculate 25, we will convert 25 gram to mole. 25 gram sodium hydroxide means 0.625 mole sodium hydroxide. So, 2.5% sodium hydroxide equal 0.625 molar sodium hydroxide solution. Sodium hydroxide gives 1 molar hydroxyl ion. So, the concentration of hydroxyl ion equal also 0.625 molar. So, now you will find out the pOH from there. pOH equal minus log concentration of hydroxyl ion, and we get pOH equal 0.204. And we know pH equal 14 minus pOH, that comes 13.79. This is the pH of 2.5% sodium hydroxide solution. Now problem 4.47 is, if the dissociation amount of acetic acid is 12.5%, then calculate the pH of 0.01 molar acetic acid. Look, here you have to calculate the pH of acetic acid solution. Look, already we have calculated the pH of sulfuric acid and sodium hydroxide, but they are strong acid and strong base. So they are dissociated 100% in solution, and we can easily find out the concentration of hydrogen ion and hydroxyl ion from there. But acetic acid, it is a weak acid, so it is not dissociated 100%. So for calculating pH of weak acid, we have to know about its degree of dissociation or acid dissociation constant, because when degree of dissociation or acid dissociation constant will be given, then you can easily find out the concentration of hydrogen ion from there. Here degree of dissociation is 12.5% and the molar concentration is 0.01 molar. Degree of dissociation 12.5%, that is 0.125, and molar concentration equal 0.01 molar. We know concentration of hydrogen ion equal degree of dissociation into molar concentration, alpha C. So from there we get concentration of hydrogen ion equal 1.25 into 10 to the power minus 3. You got the concentration of hydrogen ion. Now you can easily find out the pH of acetic acid. pH equal minus log concentration of hydrogen ion, and from there we get pH equal 2.903. Now next one, problem 4.48a. Calculate the concentration of hydronium ion and hydroxyl ions present in human blood having pH equal 7.4. Here concentration of hydronium ion and hydroxyl ion you have to find out, and their pH is given. You know concentration of hydronium ion equal 10 to the power minus pH. So if you put the value of pH here, we will get concentration of hydronium ion equal 3.98 into 10 to the power minus 8 molar. Now look, there the temperature is not given in the question, but when the temperature will not be given, then we will think that the solution is in room temperature. So we know at room temperature ionic product of water Kw equal 10 to the power minus 14. So from there we can calculate the concentration of hydroxyl ion equal Kw divided by concentration of hydronium ion, and after putting the value we get concentration of hydroxyl ion equal 2.51 into 10 to the power minus 7 molar. Now problem 4.49L. 0.25 molar HCN hydrocyanic acid solution has pH equal 5. What is the dissociation constant of it? Hydrocyanic acid is also a weak acid. So here also pH is 5 given and the molar concentration is given 0.25 molar. You have to find out the acid dissociation constant Ka. We know the formula that Ka equal concentration of hydrogen ion whole square divided by C. But here concentration of hydrogen ion is not given. Here there is given pH value. So at first you have to find out the concentration of hydrogen ion from this pH. Concentration of hydrogen ion equal 10 to the power minus pH, that is 1 into 10 to the power minus 5 molar. Now K equal concentration of hydrogen ion whole square divided by C. So after putting the value we get K equal 4 into 10 to the power minus 10. This is the acid dissociation constant of HCN. Now this is the last one. Problem 4.49 m. At 25 degrees Celsius temperature, concentration of ammonium hydroxide is 0.25 molar. Dissociation constant Kb of it is 1.76 into 10 to the power minus 5. What is its pH? Like acetic acid, hydrocyanic acid, ammonium hydroxide is also a weak base. So it is not dissociated 100% in solution. So to calculate the pH of ammonium hydroxide, we have to know about the dissociation constant Kb or degree of dissociation. Here the dissociation constant Kb is given 1.76 into 10 to the power minus 5 and the molar concentration of ammonium hydroxide is 0.25 molar. So its pH will be, at first ammonium hydroxide is, at first we will find out the concentration of hydroxyl ion. Concentration of hydroxyl ion equal root over Kb into C, and after putting the value we get concentration of hydroxyl ion equal 2.09 into 10 to the power minus 3 molar. And you know, this is ammonium hydroxide, you get the concentration of hydroxyl ion. So at first you have to find out pOH of it. pOH equal minus log concentration of hydroxyl ion. From there we get pOH equal 2.68. From there we can calculate pH equal 14 minus pOH, that comes 11.32. So dear students, I have done some math from your book, and in your book there are also some math. I know you will do all these math from the book, but this math you have no need to show me, you have no need to submit in your group. I will give you some homework, and this homework you will do in home and submit in your group. These are, there are two acids, acetic acid and sulfuric acid. Here you have to compare the pH of these two acids, and you have to compare the acidic nature, which one is more acidic between these two acids after calculating pH of them. There pH of an acid is given, you have to calculate the concentration of hydroxyl ion of the acid. 3 number. Here also pH of a solution calcium hydroxide is given. You have to find out the amount of calcium hydroxide needed to prepare the solution of 600 ml. Here acetic acid is given. Here also degree of dissociation 5.6%. You have to calculate the pH of the acid and also Ka of the acid solution. And last one, you have to find out pH of sodium hydroxide. But here sodium hydroxide, the molarity is not given. Here there is given 1 gram sodium hydroxide is dissolved into 50 ml water. So you have to find out the molarity from there. After finding the molarity, you can calculate the pOH and at last pH. So dear students, today up to this you will do this homework, and I know all you can do this math. So thank you everyone. Goodbye everyone.